Hi, my name is Devendra, metric number CN210076, and my contribution to this project is introduction. So starting up with my introduction, the most popular method for removing noise from a circuit is known as a filter circuit. There are many different types of filter circuits, but the band pass filter, which can be made with just two resistors and capacitors, is the most widely used and effective. The other categories in which the filter can be categorized will also be covered in this article. We will talk about the passive bandpass filter, which is made of capacitor and a resistor. It combines a high pass filter with a low pass filter. Following up with my uses for bandpass filters. The use of these filters in wireless transmitters and receivers is widespread. BPFs are frequently used in optics, including LIDARs, lasers, and other devices. The best use of this filter is in audio signal processing, which eliminates all but a specific range of sound frequencies. These filters can be used in applications for sonar instruments, medicine, and seismology. These filters use communication techniques to select a specific signal from a range of signals. So that's all from me. Thank you.
Hi, my name is Kuanraj Aikikandasamy and my matrix number CN210335. So my contribution to this project is doing methodology and helping my another friend to do some research about the circuit of bandpass filter so that we can do in this Proteus software. Alright, moving to the next slide. Methodology in this project is divided into three terms. So the first one is information data collection. The second one is create and simulation of an electronic circuit project. The third one is analyze of an electronic circuit. Alright, moving to the next one, information and data collection. So here, it has increased the ability to understand the knowledge of electronic communication projects. So we do a lot of research about the bandpass filter and other components. So those various information and data has increased the smoothness of the progress of the project. So we use internet as the platform to do the research, and not only that, we also researched about the simulation of the circuit. The next one is create and simulation of an electronic circuit project. So in this second phase or the second term of the whole methodology, here we conduct a simulation of the bandpass filter using a proper software. So in the circuit, there are consists of capacitors, resistors, input signals, and also output signals. This is the basic components where we have to use in doing the bandpass filter by using the proper software. Okay, in the name of proper software, we used Proteus. We select Proteus as the software where we're gonna conduct the simulation, because for me, Proteus is very I would say we have the knowledge of using Proteus. It's widely famous among engineering students, and the usage is also wide, and it's very easy to use, very easy to understand this software, and it will also help us to detect any errors in the simulation. We can troubleshoot the simulation easily, so that's why we select this electronic simulator Proteus. But we used how to say an old version of Proteus because we could not download a new one, but it's okay. We have we get a good simulation, the exact one compared to a theory, so the output is also good. About that later my friends will explain. So for now I just explain about the software we used. So it is Proteus. As in the slide, this is the circuit we have created. It consists of two sections, which is the first one is high pass filter and the second one is low pass filter. I will explain to you all slightly about the functions of these two pass filters, high and low, in upcoming slide. Alright, moving to the next phase or the last part of doing a methodology for a project, which is analyze of electronic circuit. So in this term, we have to collect the simulation results and also the theory notes, where we have to compare both of them, so that we must see whether what we did in practical, is it correct with the notes? So in this project it is proven, and because both of them are same, the simulation results and also the theory notes are compared and it is same, so it is proven. So at the same time, the function of both section of the bandpass filter, by doing this we get to know, by doing the simulation we get to know and the function, the real function of this bandpass filter, because the input signal and the output signal, where the output signal value will be different than the input. That is why the main purpose of bandpass filter. So to help us to do the comparison, the frequency response curves as give us a good support, because the theory notes has a own frequency response curve, and the simulation results has also a frequency response curve, and both of them are same. To the last slide is still in analyze of the electronic circuit. So here I can show the circuit, plus I've added in some information about the circuit, which I places high pass filter in one part, another one part is low pass filter. So let me explain about the main characteristics of these two pass filters. So for high pass filter, it will filter the low frequency, okay, from the input signal. And the second one is it will allow frequency higher than the set high cutoff frequency. Okay, same with the low pass filter, but it's just vice versa, where it will filter the high frequency from the input signal and it will allow lower frequency than the set low cutoff frequency. Okay, both of them are same but it's just opposite, it's just vice versa. So for a high pass filter, it will consist of one resistor and one capacitor with a value of 1 kilo ohm for the resistor, and for capacitor 1 nanofarad. Okay, for the low pass filter, same, it consists of one resistor and one capacitor, but the value is changed, where for resistor it's same as 1 kilo ohm, but for the capacitor is 1 microfarad. So that's all from me. Thank you so much.
Okay, Assalamualaikum and good morning. My name is Sulaiman and I will present my part on the simulation result. Okay, in this part, I use the Proteus Professional to simulate the bandpass filter and how they works. Okay, as you can see from the circuit I have drawn, I use the R1 and R3 to show the frequency graph, and the high pass filter and the low pass filter consists of the resistor and capacitor. Okay, we have the FC high and the FC low formula. For the FC high, we have 1 over 2 pi multiply R1 multiply C1, and same as the FC low, 1 over 2 pi multiply R2 multiply C2. Okay, when we get the two of them, we can find the bandwidth by substituting that FC high minus FC low. Okay, in this simulation, I use the high pass filter R1 1 kilo ohm resistor, capacitor 1 nanofarad. For the low pass filter, 1 kilo ohm resistor and 1 microfarad capacitor. Okay, we can substitute that to the formula FC high and FC low. We get the high frequency, that is 1.577 MHz, FC low 1577 Hz. Okay, this is the graph output frequency that we get from the simulation. We can see that from the graph climbs up and stay at the 1577 Hz and then climbs down back on the 1.577 MHz. That shown that the circuit only allows the frequency that is only at the 1577 Hz until 1.577 MHz. That's all for me. Thank you.
About result and discussion. So a bandpass filter filters out frequency that are too low or too high, and it will allowing only frequency within a certain range to pass through. The wireless transmitters and receiver frequently apply bandpass filters, and the primary function of such a filter in a transmitter is to limit the bandwidth of the output signal to the transmission band, and this will ensure that the transmitter does not interfere with other stations. And so the signal entering an electronic system is known as an input signal. When input signals pass through the bandpass filter circuit, the bandpass filter will allow only signals between specific frequency to pass through and attenuate frequencies outside the range. A bandpass filter can improve receiver sensitivity by enhancing the signal to noise ratio. And the dot plot of frequency response curve of bandpass filter is shown in the next slide. And so this is the block plot, or we call as frequency response curve of bandpass filter. The signal is attenuated and low frequency with the output increasing at a slope of positive 20 dB or decade and 6 dB or octave until the frequency reaches the lower cutoff point FL. At this frequency, output voltage is again 1 over sub 2 equals to 70.7% of the input signal value or negative 3 dB, 20 log V out over V in of the input. The output continues at maximum gain until it reaches the upper cutoff point FH, where the output decreases at a rate of negative 20 dB, 6 dB octave, attenuating any high frequency signals. Point of maximum output gain is generally the geometric mean of the two negative 3 dB value between the lower and upper cutoff points and is called the center frequency or resonant peak value FR. This geometric mean value is calculated as being FR2 equals to FH times multiply with FL. Okay, that's all from result and discussion. Thank you.